A million Romeos are going courting. They're racing after a human egg. It could be the start of a new life. Explore the science of sex, next on Body Atlas. Love may make the world go round, but Damien and Ruth have more than stars in their eyes. They're hoping to start a family. These young people are responding to a deep biological urge designed to ensure the survival of the human race. We humans must wait until our teens before our bodies are ready to reproduce our species. Compared with other animals, we're late developers. That's not the only difference. A woman has breasts even when she's not feeding her young. And we enjoy sex throughout the year, not just at special times of egg production. It creates a bond that holds couples together. Sex is for pleasure, but it's also for procreation. All the valentines and flowers in the world have one basic goal: to mix the characteristics of two people and make one. We all carry the seeds of a new generation. A man's sperm is one of his smallest cells, yet its head contains the germ of a new person. Its tail propels the sperm towards its much larger target, the egg. The egg is packed with nutrients and the chemicals it will need to divide and grow. It's the biggest cell in the human body, but still dwarfed by the tip of a needle. For all their differences, egg and sperm carry the same essential cargo: genes, the blueprint of the human body. The purpose of sex is to shuffle these genes and combine them in a new way. The color of our skin, hair, and eyes, our health and temperament, all are controlled by the genes we inherit from our parents. Each newborn child is unique. By constantly shuffling the genetic pack, evolution ensures that the human species keeps changing. For Ruth and Damien, the ability to reproduce started at puberty. But the potential to do so started much earlier, while they themselves were in the womb. A woman is born with her life supply of eggs. This 5-month-old girl fetus already has 7 million eggs nestling in her immature ovary. By puberty, only 300,000 remain. Human eggs constantly decay. A woman has only 30 childbearing years. A man is born with his sperm factory, but it only starts up at puberty. After that, it never switches off. In his lifetime, a man produces enough sperm to populate the world several times over. To fulfill their destiny, the sperm will have to make a perilous journey, in which millions will certainly die, and the chance of success for even one is against the odds. Conception is a game of chance. If you're trying to have a baby like Damien and Ruth, each month your chance of success is about 1 in 4. Yet our bodies and the events leading up to sex seem perfectly designed to join egg and sperm together. We begin to produce hormones at puberty. Estrogen and testosterone control the development of breasts, body hair, and sex glands. These chemical messengers change our bodies and our mental outlook. Boys begin to seek out girls, and young women start to enjoy the company of young men. Hormones not only prepare our bodies for sexual reproduction, they help us fall in love. Step 1. Boy meets girl. But what makes a person look attractive? According to the old saying, beauty is in the eye of the beholder, but science says otherwise. We all share the same view of what makes an attractive face. A law of averages operates. Scientists scanned a gallery of ordinary faces and fed them into a computer. The computer worked out an average. Offered a choice, it's this average male face which people find the most attractive. And it's the average woman who'll launch 1,000 ships. It's perhaps evolution's way of weeding out wild genes. But before the machinery of reproduction can come into play, a subtle physiological game has to be played out. Faces and expressions may be more important than words, but in the mating game, other senses have an essential role. Love and desire have a biological language of their own. Touch, smell, sight, and sound. They all produce changes in our bodies designed for one purpose: to enable sperm and egg to come together. Once a month, the pituitary gland under the brain squirts out a hormone which heads for the woman's reproductive organs. Next to the reddish womb, a bit larger than a pear, is the target for the hormone, a white ovary. In the foreground is a fallopian tube. The scene is set for the creation of a new individual. The ovary contains hundreds of thousands of eggs. They lie dormant until the monthly hormone signal triggers one to escape. The egg may have been waiting 40 years to make its debut, since the woman herself was in the womb. While the egg is safely inside the woman, the sperm factory is in the outside world. It's a dangerous place, but the testes must stay cool. Sperm will only form in conditions a few degrees below body temperature. Inside the testes are packed hundreds of yards of tubes, the breeding ground of sperm. The massive tails in this cross-section are mature sperm, awaiting delivery. Packed around the walls are the germ cells, which will develop into sperm. The complete process takes about 10 weeks. Sperm are produced at the rate of 1,000 a second. Up to 100 million are made every day. The sperm is a highly efficient machine for delivering its packet of genes to the target. At the back of the head is the power pack, delivering extraordinary amounts of energy. The whip-like tail propels it at Olympic speed. The torpedo head has a cap of chemicals that will bore into the egg. Inside is a dense mass of DNA. Unwind the DNA, and contained in its double helix is the genetic code, the blueprint for each new individual. It's packaged into bundles, chromosomes that are carried by sperm and egg. The cells that become egg and sperm start out with 46 chromosomes, like all other cells in the human body. These chromosomes divide by a special process to leave only 23. Before they divide, they go through a shuffling process, swapping genetic information to produce a unique new combination. This shuffling ensures the variety of the human species. With millions of sperm waiting in the testes and the egg about to be released, the stage is set every month for a meeting of the two. Our bodies respond to lovemaking with changes which make it possible for sperm to get inside the woman and meet the egg. The red and white areas in this thermal picture show where increased blood flow is producing heat, just one of the body's responses to arousal. Internal changes include swelling of tissues and lubrication. Skin is the most important organ of sexual excitement. Our 2.5 square yards of skin contain 5 million touch cells. They send sensory signals to the brain with lightning speed. Spread over the entire surface are areas of special sensitivity. These erogenous zones include lips, breasts, and genitals. Blood flow increases, and the heart works faster as we breathe harder to take in more oxygen. Blood normally bypasses the penis, but now its vessels dilate. The spongy tissues fill with blood, producing an erection. The sperm, till now unable to move, suddenly acquire the ability to swim. If they were as large as humans, they'd break the world record for the 100 meters freestyle. They are now propelled into the man's body to be fortified by special secretions from the prostate gland. At ejaculation, they perform a small marathon, equivalent to a man swimming 9 miles. Splashed against the woman's cervix is a flood of 700 million sperm. This is the beginning of the great sperm race, an assault course strewn with deadly obstacles. Inside the female, the sperm are now in alien territory. This is a sperm's eye view of the inside of the vagina. It's full of microscopic nooks and crannies which trap sperm. This is the gateway to the womb, the entrance to the cervix. The sperm must wriggle across these ragged skin cells. Many sperm get trapped in these crevices. Others take shelter and lurk here, releasing further sorties like waves of bombers over the next few hours. The vagina contains acid to protect it from germs. Bacteria won't flourish here, neither will sperm. 100 million are killed immediately. Most sperm die in the vagina. This sperm's survival depends on its strength and how powerfully it can swim. Ejaculation has delivered it here. Now it's on its own. Compared with other animals, the human male is rather poor at making sperm. Despite his larger testes, he makes only as many normal sperm as a hamster. Over half may be abnormal. Here's a sperm with a bent head. Some have 2 tails. Strangely, it's a disadvantage. Others have no heads. The health of the sperm is vital, but no sperm can achieve its mission unless there's an egg ready and waiting. In the ovary, a follicle is ripening, making a bulge in the surface at the lower left. The monthly surge of hormones makes the follicle burst, releasing an egg. The woman's orgasm may actually trigger it. Every 4 weeks, these fringes at the end of the fallopian tubes become activated by hormones and begin searching for the egg. They pick up the egg so it won't be lost in the abdomen. Once it's safely inside the fallopian tube, the egg has up to 48 hours to meet a sperm. Only on this particular day or two each month can a woman become pregnant. The muscular walls of the tube push the egg along. Unlike the wriggling sperm, it can't move on its own. The fallopian tubes are lined with microscopic hairs called cilia, which sweep the egg onwards. The tube walls also provide nourishment on the slow journey down to the womb. For the surviving sperm, the next obstacle is the cervix, the narrow entrance to the womb. They may find it blocked by a plug of mucus. This sticky barrier protects the woman by preventing harmful bacteria from invading her vulnerable womb. Microbes can't penetrate its fine structure. Neither can these massed hordes of sperm. Under the microscope, the mucus appears fine-woven and impregnable. But for 2 days every month, the structure changes to a wider mesh with holes through which the most energetic sperm can squeeze. This interstellar scene is mucus from the cervix, forming into crystals. At her most fertile time, a woman's internal mucus can become a microscopic work of art. Outside the body, the mucus dries into beautiful fern-like patterns. The strongest sperm can now force their way through. The mucus cleans off any bacteria they may carry. At this time of the month, the mucus also provides a safe reservoir for sperm. They can survive here for 48 hours. This pool can extend the chances of success if the woman has not yet ovulated. The woman's excitement also helps the sperm. As she reaches her climax, the pressure in her womb drops, sucking sperm through the narrow cervix and onwards towards fertilization. And there's good reason for this urgency. The egg may only have a few hours left to live. Inside the womb, the survivors form a pack to assist each other as they climb upwards against gravity. The lethal climate of the vagina has been left far behind, and the sperm are now in friendlier terrain. The wall of the womb is secreting nutrients, preparing to receive a fertilized egg. It also helps the sperm. As they take a break on the womb's lining, they are being armed with powerful enzymes to penetrate the outer shell of the egg. Now they've reached the final hurdle, the entrance to the fallopian tubes. Fewer than 1% get this far. They're faced with a choice: which tube to enter. Only one has an egg, and half the sperm get it wrong. The sperm that make the correct choice may just be lucky, or the egg may be sending out a chemical signal to guide them on their way. The pulsing walls of the woman's body assist sperm on the final leg. egg and sperm are less than an inch apart and closing fast. Only about 100 sperm eventually reach the egg. Once there, the survivors get to work at once. The sperm frantically try to bore their way in through the outer shell. They push and buffet the egg. But only one sperm can be successful. In this marathon, there are no prizes for the runners-up. The successful sperm binds to the egg's surface. An explosive charge of enzymes in its head bores through the shell. This wave of color marks the moment. It's a chemical signal sweeping across the egg. With lightning speed, the shell of the egg hardens to prevent other sperm from entering. Within a few hours of fertilization, 2 packets of genes are visible in the center, one each from egg and sperm. The 2 sets of chromosomes now reach out to each other and combine. Together, they make up the complete blueprint for a human cell. The blue patches at lower left are the sperm's gene packet. In the opposite corner is the eggs. Now the 2 sets have combined in the center. It's the signal for the egg to start dividing. Chromosomes pull apart, and the egg splits into 2 cells. After a few hours, each splits again to make 4, then 8, then 16 cells. The first few divisions of the millions it will take before the baby's ready to be born. Still smaller than the point of a needle, yet the start of a new human being. Even now, the prize may slip away. Half of all fertilized eggs fail to implant in the womb. It's lost with the woman's next menstrual period. But if they've been lucky, by day 7, the embryo is already burrowing into its mother's womb. A new life begins. The urge to reproduce keeps the human species going. We may not be a match for some other animals in the reproduction stakes, but being less fertile could be an advantage. The attraction of a couple for each other creates a secure family unit in which to rear the next generation. The human body has evolved to keep the species going and to give us pleasure as we do so. And the beginning of every life seems like a small miracle.